Hello, my math friends. This is Mrs. Schlecht, and in this video, we are going to be writing some two-step equations. All right, so before we get started, there's a few materials that you need to go get before you can begin this activity so that you can be like super duper successful. First, you're going to need your Envision book. Now, guess what, my friends? We are in volume 2. Oh yeah, volume 2, new book, super exciting. Second, you're going to need your math notebook so you can take those beautiful math notes and show all of your wonderful thinking. Third, don't forget that pencil. And fourth, last but certainly never ever least, that positive math attitude. All right, my friends, so this video goes very well with lesson 5-1 and again, volume 2 of our Envision book. Super exciting. So in this video, we're going to go over writing two-step equations, all right? So we're gonna read some information and then we're gonna see how we can translate that into like some math speak, okay? Now, the key concepts can be found on page 266. All right, my friends, so the first problem that I'd like to look at together is actually the Explore It example on page 263. Now, you're probably like, Mrs. Schlecht, why are you doing this example? You typically don't do the Explore It's. Because there's a pug. There's a pug. How sweet is that? All right, so here's the story. We have Marley, who's like a Scotty, I'm thinking, and then we have Tucker the pug, Precious. And what these little friends do is they collect golf balls, okay? So that's like the basis of the story, is that they collect golf balls. But the puglet, because Tucker is just such a go-getter, collects more, right? Now, how much more? Glad you asked. Tucker, the pug, collects 3 more than twice as many golf balls as Marley, okay? 3 more than twice the amount of Marley, all right? So first, there is like some tables and stuff that it's gonna ask us to do, but let's just think, how can we represent 3 more than twice? So let's think, more. Now, what operation could represent adding something, like adding more of something? And then if I say something is twice as many, what operation might that represent? All right, my friends, so what I've done is I've taken this little story that we had right here, and now I've put it using some numbers and some symbols to represent what the heck was going on here, right? So Tucker's golf balls are a little precious pug who's just such a go-getter, right? We know that the number of golf balls that Tucker has is equal or the same as 3 more. So we're representing that by 3 plus, right? Addition is adding more, right? Plus what? Twice as many golf balls as Marley. So we can say it's 2 times Marley's golf balls. Now you'll notice, instead of using the X for multiplication, I just put that little dot right there, right? Because we're gonna start using some variables, and I wanna make sure that we are all on the same page and we know that we are representing multiplication and not a variable X, right? So again, we can represent this story problem by saying Tucker's golf balls equals or is the same as 3 more than twice the amount of Marley's golf balls, all right? Now, how can we represent this just using some variables? Ta-da! So now all I've done, my friends, is I've just shortened it a little bit, right? So instead of having like all those words, Tucker's golf balls, Marley's golf balls, all I'm doing is I'm using T for our Tucker, the pug, right? And then I'm using M to represent Marley's amount, right? Now let's look at part A. All right, my friends, so now in part A, it's asking us to use a table like so to kind of see this relationship and see these patterns in action. So let me explain what I've done. Now up here, this is our handy dandy little algebraic expression, my friends, that represented that entire story, right? That Tucker's golf balls was equal or equivalent or the same as 3 more than twice Marley's amount, right? Okay, so over here, I have Marley's amounts. Now you're probably wondering, Mrs. Schlecht, where did 10, 11, 12, 13 come from? Right up here in my head. And it's also kind of like in your book, at least in my version of your book. So I don't know, maybe it's there, maybe it's not, I don't know. But the point is, this right here is your independent variable, right? So I can start wherever I want to. So I'm just giving Marley the benefit of the doubt. He has 10, 11, 12, and 13 golf balls to start out with, right? Over here in this column, that's going to be representing our twice as many, right? Our multiplication piece. And over here, my friends, in this column, we're going to be representing that 3 more, right? So we'll start with that twice as many, and then we're going to do 3 more than that amount. And over here, oh, Tucker the pug, we'll just see how fabulous he is, all right? So first, let's start with 10. So if Marley starts with 10, then what would be twice as many as 10? All right, so if Marley had 10, twice as many as 10, 2 times 10, boom, 20. Now, what's 3 more than 20? So we take 20 because that was twice as many as where Marley started. 20 plus 3, it's 23. I know it's kind of tiny, 23. So now, what's our fabulous little Tucker the Pug have? Check Tucker out. He's got 23 golf balls, right? So let's just refresh what we just did, all right? Marley started with 10. That's a good amount, right? Then we know that Tucker's amount is twice as many, so that's 2 times 10, that gave us 20. But 3 more than twice as many. That's why we added that 3, and that gave us, boom, 23. Way to go, Tucker the Pug. Now, let's continue this pattern for the rest of our table. Next, let's say that Marley, our little Scotty, starts off with 11. How many does our friend Tucker the Pug have? 25. Mrs. Schlecht, how in the world did we get 25? I'll show you. So we took 11 and we multiplied it by 2, right? Because it's twice as many. So that gave us 22. But it's not just twice as many, my friend. It's also 3 more than twice as many, right? So we have 22 plus 3, which gave us 25. Boom. Tucker, the friendly, most beautiful pug, has 25 golf balls. Now let's check out 12 and then 13. All right, my friends. So now we know what 12 and 11 Marley golf balls really means for Tucker the Pug's golf balls, right? So let's look at number 12. So we took 12 and we multiplied it by 2 because that represented that twice as many, and that gave us 24. But that's not all. Then we took that 24 and we added 3 because it was 3 more than twice as many. Boom, 27 for our little Tucker the Pug. Love him. Now let's look at 13, all right? So we took 13 Marley golf balls. We multiplied it by 2 because Tucker had twice as many, right? But wait, there's more. We took that twice as many and then we added 3 because it was 3 more than twice as many. Boom, 29 golf balls for Tucker the Pug. Now real quick, you're probably noticing, hey, Mrs. Schlecht, Tucker's golf balls amount, they're just going up by 2. Now, the reason they're going up by 2 is because Marley's going up by 1, but then we're multiplying it by 2, right? And 1 times 2 is 2 more. So I know that it looks like the pattern here is just adding 2, but we are so smart, brilliant, and beautiful, we know that actually it's more of a pattern, right? So now what I want to do is let's ditch the table, all right? And let's play around with this expression a little bit. So now, my friends, notice table, it's all gone, but that's all right. We can still do math, which is super, super exciting. So what I've done now is we're going to use M, right? That's our variable to represent the amount of golf balls that our friend Marley the Scotty has, right? So I, again, just made these numbers up. It's not in your book. It just came from right up here, right? These are our independent variables. That means that they are independent, right? So we can kind of start wherever we want to start. So we're going to do 15, 9, and 20, right? These are going to be our different solutions to M. And what we want to do is, instead of using that table, let's just plug it into this beautiful algebraic expression to find out how many golf balls Tucker would have in these different situations. So let's start first with M equals 15. So when Marley has 15 golf balls, we know that we can represent that by plugging in 15 right over here for M, right? So we'll have 3 plus 2 times 15. Now, order of operations, right? That tells us that we're going to be multiplying first. All right, so 15 times 2 is 30, which means we'll be doing 3 plus 30. Boom. Tucker the Pug has 33 golf balls. Now, we're going to be looking at Marley's 9 golf balls, my friends. So we know that that's going to be 3 more than 2 times 9, right? Twice as many as the 9 golf balls where we started. So 2 times 9, 18, always and forever, right? And then we're going to be adding 3. That means that Tucker, the magnificent pug, has 21 golf balls. All right, how about if Marley has 20? What's that mean for our little pal Tucker? All right, my friends. So again, if Marley has 20, what we would do to find out Tucker the Pug's quantity is we would take 2 times 20 because it's twice as many, right? Plus 3 more, right? So we know that 2 times 20 is 40. 40 plus 3 would be, boom, 43. Now, the moral of the story is that pugs are just fantastic, and they're just one little go-getter when it comes to collecting golf balls. All right, my fabulous friends, so there's one more problem I would love to look at together. It's on page 266, and it's number 6. And it's about our friend Kaylee. Now, Kaylee babysits for 11 hours this week. 11 hours. No more, no less. It's 11 hours. That was 5 fewer than 2/3 as many as she babysat last week, which we're using H to represent last week's hours, okay? Now write an equation to represent the number of hours she babysat each week. Now a couple of things to look at. I know that there is a fraction. I know that. But can I tell you something? Come here, can I tell you something? Just because there's a fraction doesn't mean that all the math we just did goes out the window, okay? Fractions are just numbers. It's okay. You can do it. Do you remember in that last problem it said twice as many, right? Twice as many, 2/3 as many. And what operation did we use to represent that twice as many? And likewise, in that last problem we did about Tucker the pug and, Marley, it said 3 more, and we used addition, but this says 5 fewer. So what operations might we be using to represent this situation? So, my friends, we can use this algebraic equation to represent this whole situation, right? So the 2/3 as many, we're going to use multiplication to get that piece, right? So it's 2/3 times H, H being the number of hours. Now remember, when you have a coefficient like this fraction, and it's next to a variable like this H, and there's no sign in between, that actually means multiplication, right? So right here, this 2/3 H means 2/3 times H. But wait, there's more, because it's 5 fewer, fewer meaning less, less meaning subtraction, right? So then we're going to subtract 5 from that, and that is going to give us 11, okay? So again, this is the algebraic equation that we can use to represent Kaylee's babysitting hours. All right, my friends, that was just a quick run through over lesson 5-1, which showed us how to write these 2-step equations. As always, if you have any other questions, please let me know.